Hello and welcome to my channel. I am Nelson Augustine. Please, if you're new here, kindly hit the subscription button. And if you have been watching my videos and you have not subscribed to my channel, please kindly subscribe to my channel for us to build a mathematics community. In this lesson, you're going to look at how to differentiate implicitly, how to do implicit differentiation. So watch as we do. You'll be taking a lot of examples that will help you in your exams. Now, if I have y is equal to x squared minus 2x plus 5, here we said that y is being explicitly defined, because if I put in let's say x is equal to 1, I will not worry myself rearranging this to make y the subject, because y has already been made the subject. But if I write, let's say 5 x minus 2y equal to 8, here I have to make y the subject first before I can substitute a value for x and then find y. So here we say y is being implicitly defined if we concentrate on y. So today we'll be doing implicit differentiation. Now let's start. If I have y squared is equal to x, here what do? I'm going to differentiate this implicitly. Now, here we are going to have first, if we represent g equal to y squared, then we are going to differentiate this y squared with respect to x. So what do? We take the derivative of, we are going to differentiate g with respect to x. So we take the derivative of g with respect to x equal to derivative of y squared with respect to y. That is the g. This is the g. So we take derivative of g with respect to y. But here g is y squared, no problem. Times, there's no need putting it in brackets. Times, now we are using the chain rule, so there should be a chain, so that this y squared will go away for us to get derivative of g with respect to x. So here it means that I need dx at the denominator here, and then dy at the top here, so that dy will cancel dy and have dg on dx. Very simple as that. So now let's differentiate. So here we are going to have derivative of g with respect to x is equal to dg on dy. And what is g? Y squared. So we are going to have dy, we take the y squared, times derivative of y with respect to x, so that we can maintain the chain. So this will give us, if we differentiate y squared with respect to y, we are going to get 2y, and we have our dy on dx. Very simple as that. So here, if I'm going to differentiate y squared with respect to x, this is the answer that I'll get. I'll get 2y dy on dx equal to, if we differentiate x with respect to x, you get 1. Now what will happen? If I want dy dx, I'll just divide through by 2y. So here, I'll divide through by 2y to get my dy on dx equal to 1 divided by 2y. Very simple as that. Now let's take the next example. If we have, let's say, y cubed to be equal to xy. Now, you know that from the chain rule, we will differentiate this with respect to y, and then we multiply it by dy on dx. So here, I'm going to have the derivative of y cubed with respect to the same y times dy on dx. That is the chain rule. Equal to, here we are going to use the product rule. So you maintain the y and then differentiate x with respect to x, plus, here this is y. So what do? We maintain the x and then you differentiate y with respect to y times the derivative of y with respect to x. That is the chain rule. So that we will get dy with respect to x. So if here we differentiate y with respect to y, we're going to have 3y squared times dy on dx. That is equal to, if you differentiate x with respect to x, you get 1 times y is y. Plus, if you differentiate y with respect to y, our answer is 1 times dy on dx will give us dy on dx times x will give us x dy on dx. Wow. So now we can group the dy dx term together and then we move on. So here we are going to get 3y squared dy on dx minus x dy on dx equal to y. So what do? We can factorize the dy dx term out. So we have 3y squared minus x dy on dx to be equal to, and here we write y. So I prefer writing this in this form because if we write it as, let's say, dy on dx into bracket 3y squared minus x, it looks like we are coming to differentiate this. So whenever you are factoring, just factorize the term here and then let the derivative be at this side so that it will not confuse you. Okay, so we are going to have the derivative of y with respect to x to be equal to y divided by 3y squared minus x as our final differentiation. So here we are not going to be proving again. So simply, if I have, let's say, y to the power 4 equal to x, and I want to differentiate this y implicitly with respect to x, the word is implicitly, what I'll do is that I'll differentiate this first with respect to itself, that is with respect to y. So I'm going to get 4y cubed and then multiply dy on dx. Since I am differentiating this implicitly with respect to x, the dy on dx should be multiplied by it. Very simple as that. So for instance, if we have, let's say, let's say 2a is equal to t, and I'm going to differentiate a implicitly with respect to t. I'm going to differentiate a implicitly with respect to t, then I'll differentiate 2a with respect to a. So I'm going to get 2 times, I have to differentiate a with respect to t, so times dA on dt. And here if I differentiate t with respect to t, I'm going to get 1. So here, the derivative of a with respect to t will give me 1 on 2. Very simple as that. I did this to emphasize the understanding. So here, if you are to continue on this, if we differentiate x with respect to x, you get 1. And we divide both sides by 4y, keep to get dy on dx to be equal to 1 on 4y keep. Now let us do more difficult examples. Now the next example, we are going to consider 5x cubed y squared is equal to 3x minus 4y to the power 2. Now let's go through this derivative. Now here, 5 is a constant, so we will factorize the 5 out. Now this one, you have to use the product rule. So here, you maintain the y squared and then differentiate x cubed with respect to x. So we put this in brackets plus you maintain the x cube and then differentiate y squared with respect to x. This will be equal to, you differentiate 3x squared, 3x, so d dx 3x minus d dx 4. Let me bring it here. Minus d dx 4y squared. Now let's do it. So here we have 5 being constant. Derivative of x cubed with respect to x is 3x squared times this will give us 3x squared y. And then we are differentiating y squared. So what do? We differentiate y squared with respect to y. It will give us 2y. And then we have to multiply it by dy on dx. So here we are going to get 2y dy dx times x cubed. So here we are going to get plus x cubed 2y dy on dx. And we close the bracket. And this is equal to, if we differentiate 3x with respect to s, we get 3. Now if we differentiate 4y squared with respect to x implicitly, we are going to get negative 8y dy on dx. Very simple as that. So I'm going to multiply through by the 5. And this will give me 15x squared y plus, here the 2 is here. So I'm going to get 10x cubed y. In fact, I should have written 2x cubed y like that. 10x cubed y dy on dx to be equal to 3 minus 8y dy on dx. So you can group the like terms. You have 10x cubed y dy on dx minus 8y, plus dy on dx equal to 3 minus 15x squared y. Wow, that is very, very nice. Let me use this marker. I hope you are enjoying the lesson. Now, you factorize the dy dx out. So you are getting 10x cubed y plus 8y dy on dx to be equal to 3 minus 15x squared y. So we divide through by 10x cubed y plus 8y. So we have the derivative of y with respect to x to equal to 3 minus 15x squared y divided by 10x cubed y plus 8y. That's our final answer. Now let's take the next example. In the next example, we are going to consider this one. We are going to consider x to the power 3, y to the power 5, plus 4xy plus x minus 6y equal to 3. So how do you do this one? So here we are going to use the product rule. So let's what? We maintain the y to the power 5. If we differentiate s cubed with respect to s, we are going to get 3x squared. Plus, you maintain the s cubed and differentiate y to the power 5. And that will give us 5y to the power 4. And since we are differentiating with respect to x, implicitly you will bring dy on dx. Please, the emphasis here is implicitly. If it is not implicitly, y will become a constant and the derivative of y with respect to x, you may get it 0. Are you there? That is that. Like if I write, let's say a plus a equal to 3x minus y, and if I want to find the a on dx, here the derivative of a with respect to x is equal to 3. Here this one will be 0 because it becomes a constant. But here we are differentiating the y implicitly with respect to x. So here y there is not a constant. You should be very careful with that. You see that here it is dA on dx. Correct. Here we are doing implicit differentiation. So the y there is not a constant. That is why we have multiplied it by dy on dx to show that we are doing implicit differentiation. So now we are going to get this as plus. If we differentiate x with respect to x, you get 1. If you differentiate 6y with respect to y implicitly, we are going to have derivative of this with respect to y will give us 6 times dy on dx. So we are going to have here minus 6 dy on dx equal to, if we differentiate 3 with respect to x, it is 0. Here 3 is a constant. Now let's move on. So we are going to have 3x squared y to the power 5 plus 5x cubed y to the power 4 minus 6 dy on dx is equal to negative 1. Very simple as that. Okay, now let's take this one to that side too. So minus 3x squared y to the power 5. And then clean it from this side so that we can go fast. So here what do we do? There is dy dx here, I didn't write it, so let me bring it. So that is 5x cubed y to the power 4 dy on dx. So we are going to have 5x cubed y to the power 4 minus 6 dy on dx equal to negative bracket 1 plus 3x squared y to the power 5. So negative times positive will give you negative, negative times positive will give you negative. So you divide through by this. We have the derivative of y with respect to x to equal to negative into bracket 1 plus 3x squared y to the power 5. All divided by 5x cubed y to the power 4 minus 6 as our final answer. Now let's consider the next example. Now the next example is this one. We have the question is, we have y equal to x minus y divided by x. So how do we differentiate this implicitly with respect to x? So here we are going to multiply this. Here we are going to have yx is equal to x minus y. These are very simple. I'm not going to use the chain rule, the quotient rule rather. You can also use the quotient rule to obtain the same answer. So now let's move with this. So here what do we do? If we maintain y and differentiate x with respect to x, plus we maintain x and then differentiate y with respect to x, and this will be equal to the derivative of x with respect to x minus the derivative of y with respect to x implicitly. So here dx on dx is 1, so 1 times y is y, plus x dy on dx, because if you differentiate y implicitly with respect to x, you get dy on dx. If you differentiate x with respect to x, you get 1. And if you differentiate y implicitly with respect to x, you're going to get dy on dx. So we group that when we have x dy on dx plus dy on dx is equal to 1 minus y. And here we have x plus 1 dy on dx to be equal to 1 minus y. And here dy on dx will be equal to 1 minus y divided by x plus 1 as the derivative of y with respect to x. Now, note that here we can proceed to remove y because here we can make y the subject. So let's make y the subject from this equation. So from here, we can group like terms to get yx plus y equal to x. And here we have y into bracket x plus 1 equal to x. This implies that y is equal to x divided by x plus 1. Have you seen that? So whenever you find y here, we are going to put in x divided by x plus 1. So let's do that. We are going to have the derivative of y with respect to x to be equal to 1 minus, let me do it here. The derivative of y with respect to x will be equal to 1 minus x divided by x plus 1 or divided by x. Okay, let me bring this one here. Or divided by x plus 1. And here remember to put this in brackets. If you forget to bring the brackets, it means that the division sign is only dividing the x. So we put this in brackets. Now let's simplify this. Here the LCM is x plus 1. So 1, this 1 is over 1. 1 divides this x plus 1 times this. We are having x plus 1. X plus 1 divided x plus 1 times x will give us negative x. dy on dx times 1 divided by x plus 1. So we turn this one upside down. So here what will happen? This negative x will cancel this positive x, and we are going to have 1 divided by x plus 1 times 1 divided by x plus 1. So this will give us 1 divided by x plus 1 squared, or 1 divided by, this will give us x squared plus 2x plus 1 if we expand this. Wow. Now let's see if the quotient will give us the same results, or you try that one yourself. Let's see if the quotient will. So let's put this final answer here. We have dy on dx equal to 1 minus y divided by x plus 1, and see if the quotient will give us the same results. Yes, this is Papa. Keep watching and then like, subscribe, and share the videos for other colleagues to also enjoy these amazing videos. So here, if you want to use the chain rule, dy on dx is equal to, you differentiate the top function times the down one. So you have x, then you differentiate x minus 1. Sorry, x minus y, minus, we maintain the top one, x minus y, and we differentiate this one. So we have ds of x, all divided by x squared. So we have the derivative of y with respect to x to be equal to, so here what do we do? Here we have x, and here how do we differentiate this? We have to differentiate it term by term, because the sign here is not multiplication, this subtraction. So this one will be the same as ds of x minus dx of y. That's how it's going to be. So if you differentiate the x with respect to s, you get 1. If we differentiated the y with respect to x implicitly, we are going to get dy on dx minus x minus y times 1, because if you differentiate x with respect to x, you get 1, all divided by x squared. Now let's see. Here we are going to have the derivative of y with respect to x to be equal to x minus x dy on dx minus x plus y, all divided by x squared. Wow. So let's see. We multiply through by this. We are going to have x squared dy on dx to be equal to x minus x dy on dx. And here what do we do? This minus x will cancel this positive x. So this one will not come. But here we have the negative sign there. So we have here as plus y. Now, we are going to have to clean the top. We are going to have x squared dy on dx plus x dy on dx is equal to y. And now you have x squared plus x times dy on dx is equal to y. And this will give us dy on dx to be equal to y divided by x squared plus x. Now, we can make y the subject and then come and put it here. And let's see what we will get. So I'm cleaning this one. So here, if we make y the subject equal to this, so I'll place that one there. So I'm going to have dy on dx to be equal to x divided by x plus 1 divided by x squared plus x. And this will give us x divided by x plus 1 times 1 divided by x squared plus x. So let's see. So this will be equal to x divided by this one can be simplified or can be factorized as x into bracket x plus 1. So we are going to put that one here, x into bracket x plus 1 for this, and we have times x plus 1. So we are going to get this x cancelling this x, and that will give us 1 divided by x plus 1 squared, and that is what we have here. Have you seen that? Very simple as that. So if we go through the what do you call it, the quotient rule, we will get the same result. That is what we've done there. So let's take the next example. So you see that the first answer that we had was not equal to it, but if you substitute in values of x and y, the answers will be the same. The answers will be the same. I shouldn't have cleaned it. I should have tested that one for you to see. But it's gone. It is gone. I think we had y equal to we had y divided by what? X squared plus x. So let's check and see. Let's move on. Let's move on. Try that one yourself. Let's move on. Yes, you will believe. So the next one we are going to consider is I have y squared minus 9 to the power 4 is equal to 4x squared plus 3x minus 1 squared. So here we are going to differentiate this implicitly with respect to x. So what do we do? Here we are going to use the chain rule. So check the description for my video on derivative using the chain rule, derivative using the quotient rule, and then using your head to do the chain rule. You can do the chain rule in your head. It is in the description, or you can comment at the comment section. Then I'll send you the link there for you to watch that video. So we are going to use the simple method for the chain rule. This one will come and multiply. So you're having 2 times the original expression inside. Then we take 1 from the power times, then we differentiate what is inside here. So we're going to differentiate y squared minus 9 with respect to x, and this is equal to, we are going to use the same chain rule, so the 2 will come. So we have 2 times the original function inside, 4x squared plus 3x minus 1. Then subtract 1 from this to get 1 times the derivative of 4x squared plus 3x minus 1. So here, what do we get? If we differentiate, this is 4. Why did I write 2? If we differentiate this one with respect to, implicitly with respect to s, we are going to get 2y dy on dx. Because the derivative of 9 with respect to x is 0. For that 9 is a constant. So we multiply this one by that to get 8y into bracket y squared minus 9 keep dy on dx. Note how we differentiated this. This one is the same as d dx y squared minus d dx of a constant. So if we differentiate this, you get 2y, then multiply divide here by it. If we differentiate this, you get 0. So that is why we get this. So if you multiply this by that, 2y will multiply the 8. Sorry, we multiply the 4 and get 8y. So this is equal to 2. If we differentiate this, we get 8x plus 3. So 2 times 8x plus 3 times 4x squared plus 3x plus 1. And we differentiate 2 by this. Sorry, what we divide 2 by this, we have derivative of y respect to s is equal to 2 into bracket 8x plus 3 times 4x squared plus 3x plus 1. All divided by 8y into bracket y squared minus 9 divided by 3. Remember, you cannot multiply 2 by 8y since this one has a power. Now, we can eliminate y squared minus 9 from this. So let's see how we do the elimination. Now we see that we have y squared minus 9 to the power 4 to be equal to 4x squared plus 3x minus 1 all squared. So what do we do? If we take the fourth root of this, that is by raising this to the power 1 out of 4 and then raising this also to the power 1 out of 4, we are going to have y squared minus 9 to be equal to 4x squared plus 3x minus 1 to the power half. Wow, to the power half. Very simple as that. Or 2 times 1 out of 4 is half. So here, this one can be factorized as y squared minus 9 times y squared minus 9 squared. Or here, since they are the same, 1 plus 2 will give us a 3. So now we've found an expression for y squared minus 9. We have to find another expression for y squared minus 9 all squared. Here, let me put this one there. So this one is the same as 2 into bracket 8x plus 3 times 4x squared plus 3x plus 1 divided by 8y. So this one, we've gotten one of the term. So that is it. So let me put it there. 4x squared plus 3x minus 1 to the power half. Remember that I've said that this is the same as writing 2 into bracket 8x plus 3 times 4x squared plus 3x minus 1 divided by 8y times y squared minus 9 times y squared minus 9 all squared. So now you've substituted for y squared minus 9. We are going to do another substitution for y squared minus 9 squared. So here, you can use the same thing here. So let me clean the powers. Then we can move with it. So, I want squared. So what do? I have to multiply this. Sorry, I have to raise this to the power half. And raise this 1, 2 to the power half. So 4 times half will give me y squared minus 9 squared. And 2 times half, I'm going to get 4x squared plus 3x minus 1. That is 2, we'll cancel the half. So y squared is this. So we are going to multiply this by 4x squared plus 3x plus 1. Wow. To replace y squared minus 9 all squared. So here this term will cancel what we have at the top. Wow. And we are going to have 8x plus 3 divided by 4y times power half means square root. So I'll bring the square root of 4x squared plus 3x minus 1. Very simple as that. Wow. That is very, very nice. That is very, very nice. So let's proceed to the next question. So you see that it's a very nice procedure that we've gone through to reach this level. So we try learning how we are doing the simplification, how I'm doing the simplifications. It will help you. It will help you very, 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 very well. Look at how we differentiated this and how we substituted. Just go and watch the videos on how to use the chain rule for the differentiation. Very simple. Here we said that we bring these two here and we got it here. Very simple. And then you write the original function down. And that is the original function. Then you differentiate the inner function. 2 times 4, 8. Then here you get 3. Then you move with it. So do well to get these things fast. Now let's see. Let's see the next example. And that one will be the last example. If I have 1 divided by x squared plus 1 divided by y squared equal to 1. Now this is the same as x to the power negative 2 plus y to the power negative 2 equal to 1. So you differentiate this with respect to x, you get negative 2y to the power negative 2 x to the power negative 3. And if you differentiate this implicitly with respect to x, I'm going to get negative 2y to the power negative 3. Then we attach dy on dx. If you differentiate this with respect to x, you get 0. So now what do? This one is the same as negative 2 divided by x cube minus 2 divided by y cube dy on dx equal to 0. So let's send this one here. We have minus 2 on x cube to be equal to 2 on y cube and dy on dx. So if you want to find dy dx, we divide this one by 2 divided by y cube. So we are going to have our dy on dx to be equal to negative 2 divided by x cube divided by 2 on y key. And this implies that we are going to get negative 2 on x key times y key on 2, and that will give us negative y key on x key as our final answer. And I think I've done enough to bring your understanding. So this is where we will end. Thank you for watching, and please subscribe to my channel. Bye bye.